Good day guys, welcome back to my channel. Today I want to talk about how to check if a Dumpy level is faulty or if it has an error. So the method used to check if a Dumpy level has an error is called two-peg test. That's the simplest and easy method. So two-peg test is just the process involves checking level for two different positions and changing instrument station at the same time. What did I mean? Assuming this is a relatively flat terrain, and you set your level instrument here. You measure 30 meters to the front, 30 meters to the back. You make sure that you set a particular point here that is relatively plain, and here too. So the first step is that you take your reading. I assume this to be my point A, I assume this to be my point B, and I assume this to be my station 1, which is I name P1. As you can see here, the second stage, I changed my station to be 10 meters away from point B. Initially, my station was positioned at the center of the 2 points, 30 meters away. So to start with, I take my reading at point A. I put it down here to be 1.492. As you can see, I rotate my instrument to point B. I take my reading. I put it down to be 1.172. As you can see here in this table, my point station 1, which is the center, which is P1, my reading at point A is 1.492, and my reading at point B is 1.172, as you can see. So after that, I change my station. I carry my instruments. The second stage, I carry my instruments 10 meters away from point B. I take my reading. I observe my reading to point B to be 1.199. I then observe my reading to point A. This same point A, what only changed was the station of the instruments. 30 meters away initially and 10 meters away from point B. But this point where my staff was positioned does not change. Point A and point B. Point A and point B. So after I took my reading to point B, I took my reading to point A, then I have this table. This is point A, this is point B, this is my first station where I set my instrument, and this is second station where I set my instrument. This is the data that I got. At my first station, point A, I observed 1.492. As still the same first station, point B, I have 1.172. I change my station 10 meters away from point B. I observe my reading to point A to be 1.498. I observe my reading to point B to be 1.199. So difference between A and B which is at this same point A, difference between my readings at this same station 1 P1, difference between my readings A and B, which is it might be A minus B or B minus A, whichever greater. So from here now, I realize that A is greater than B, which is 1.492 minus 1.172, which I got this. Automatically, this is A minus B. So at point 2 also will be A minus B. It won't be B minus A, but automatically A will be more than B. So my difference now was 0.32. If I check the difference between 1.492 and 1.172, it's 0.32. And then at my second station, point 2, which is 1.498 minus 1.199, I got 0.299. So the error between the instruments will now be gotten to be the difference between these two, which is the difference between the point A and point B after I finish my readings. So which is from here now, A minus B is 0.32, and A minus B here also at point 2 is 0.299. The difference between the two might be P1 minus P2 or P2 minus P1. From here now, from my readings now, it is P1 minus P2 because 0.32 is more than 0.299. So if I subtract 0.32 minus 0.299, I will get 0.021, which is 21 mm, 21 millimeters. So ideally, if in a normal condition, there is no error due to parallax, different in points where the staff was placed. No, all these things is prone to some slight error. You understand? So, but I think if you have data like this after checking your instruments, if you have data like this and you have like difference of error of 21 mm, I don't think that your instrument is faulty, because this 21 mm is still it might be due to maybe the way you observe your reading, parallax error. It might be due to maybe the way you place your staff, the way the chainman handle the staff and all. So, but if it's beyond, let's say 25 mm and above, it is possibly that the instrument is faulty. But ideally, the difference between A and B, difference between points P1 and P2, which is 0.32 minus 0.299, supposed to be 0. We are supposed to have the same value here. If there is no error in positioning, in parallax, and everything, assuming everything is fine, which might not be possible or achievable. That's why there is a range for possible errors. Thank you, guys.